So if we let y be the uniform distribution on 0, 1, and we let x sub n be the y to the power of n, we want to show that x sub n converges to 0 in probability. So before we get started here, let's just think for a moment about the definition of converging in probability and how that would apply here. So really all we're doing is we're taking our definition, and now we have the limit as n approaches infinity of the probability of the absolute value of x sub n minus 0 greater than or equal to epsilon equals 0. That's what we want to show. That's how we prove that x sub n converges to 0 in probability. So now you might immediately have the urge to simplify this, and that would be the right urge. So let's do that here. If we just look at our term, not our limit, our probability term, sorry, and we plug in our definitions. So we're just plugging in the fact that x sub n equals y to the power of n. That's where our first equality comes from. Then, because y is only defined on 0 to 1, that's our support, y to the power of n is obviously always positive, so we can drop our absolute value. And then from there, our last inequality just comes from the fact that when you have y to the power of n, we can just do epsilon to the power of 1 over n, right? And now you might start to see kind of where we're going with this. So if I plug that back into our limit, we have this huge thing down here, where essentially the fact that our limit of our simplified probability equals the limit of as n approaches infinity of 1 minus epsilon to the power of 1 over n. That equality comes just from the properties of the uniform 0, 1 distribution. So then from there, right, we can move our limit around a bit. And then since we have epsilon to the power of 1 over n, we know that that becomes epsilon to the power of 0 as n approaches infinity, right? And then we're done.